In this question, we are given that the researchers on the board are investigating plankton cells in a sea, and at the depth of h meters, the density is given by this function for h less than 30 meters, and then by another function f of h for h deeper than 30 meters. And so h is not given to us. So we need to find the derivative of the function p and evaluate at h equals 25. And what is the meaning of that function? So of that value. So really we need to do p prime and 25 and use a calculator to evaluate that. And we will do that next. And what is this? The number will represent the density of plankton cells that will be changing at this rate at a depth of 25 meters, and the units will be millions of cells per cubic meter per meter. So it's a mouthful. It really is millions of cells per cubic meter, or millions of cells per meter to the fourth power. So let's now calculate this numeric value using the calculator. So let's find the derivative of this function at h equals 25. So we do mathematics, derivative with respect to x of the function 0.2 times x squared times e to the power negative 0.0025 times x squared. And notice that it doesn't matter whether we use x or h as long as we use the same variable here. And so x equals 25. Enter. And so the answer is negative 1.179 thousandths. So that's at that depth of 25 meters, the density of plankton cells is changing at this rate. And as we said, million cells per cubic meter per meter. So in this part of the question, we need to find how many plankton cells are in the column of water between h equals 0 and 30 meters, such that the horizontal cross-section is a constant area of 3 square meters. And so what we really need to calculate here is integral from 0 to 30, 3 times p of h ph. P of h is the function, density function here between 0 and 30, so we use p of h, we don't need f of h. And so let's do that using the calculator now. Let's calculate this integral here. So mathematics, integral from 0 to 30 of 3 times the function 0.2 times x squared times e to the power negative 0.0025 times x squared dx. Let's calculate this. And we get that there are 1,675.415 thousandths million plankton cells in the column of water between 0 and 30 meters. So in this part of the question, we are given another function u such that it's greater than f of h for all h greater than 30, and that integral of this function from 30 to infinity exists and equal 105. And so we are now being asked to write an expression involving one or more integrals that gives the number of plankton cells in millions in the entire column defined in part B but where k is greater than 30. So it was extended beyond 30. So that integral, or that expression, is given by integral from 0 to 30, 3 p of h dh. That is what we had in part B, plus additional element from 30 to k, 3 f of h dh. So this is the exact expression for the number of plankton cells in the entire column. This number we calculated in part B, and this is 1,675.415 millions of cells. And so we need to approximate this number, or find the maximum on it. So this integral 3 f of h dh from 30 to k less than or equal, because f of h is greater than 0, we can just extend this limit to infinity. It's less than or equal than 330 to infinity f of h dh. And then because pointwise f of h is less than u of h, less than or equal, then this is less than or equal than 3 integral from 30 to infinity u of h dh. And this integral we are given is equal to 105. So 105 times 3 gives us 315. So the upper limit on this integral, this is less than or equal than 315. So adding these two together, we can see that the sum of these two integrals is less than or equal to 1,990.415 thousandths, which is less than 2,000 million cells that is given to us as something we need to prove that the sum of these two integrals is less than or equal to 2000. So this completes the proof here. In this part of the question, we are given that the board is moving on the surface of the sea, and that at time t greater than or equal to 0, the position of the board is x of t and y of t, and the change in x and change in y, so velocity along the x-axis and the velocity along the y-axis is given by these two expressions. And then we have to find the total distance traveled by the board over this time interval 0 to 1. And so what is this expression? We need to find integral from 0 to 1 v of t, velocity of this board dt. And so what is this velocity of the board? It's just v of t is equal to the square root of the two velocities, x prime of t squared plus y prime of t squared. And why is that? Because here is our change y prime of t velocity in this direction, here is our change x prime of t in this direction, and so the velocity, overall velocity, is given by the Pythagorean theorem, which is this v of t, which is exactly, we are just finding x1 squared plus y prime squared, square root of that gives us the absolute value of the velocity. And this has to be absolute value of that velocity. So let's do the calculation using the calculator. Let's now calculate this integral, and so we go to mathematics, integral, and we have integral from 0 to 1 of a function which is the square root of the expression in parentheses x prime of t, which is 662 times sine in parentheses, we already have one, so in parentheses 5 times x, close parentheses, squared, plus, and now in parentheses, y prime squared, 880 times cosine of 6 times x, close parentheses, squared, dx. Let's calculate that. And we see that the total distance traveled by the boat over this time interval from 0 to 1 hour is 757 meters, 0.456 thousandths meters. Thank you, and I will see you in the next video.